the content on lecture 3. In this video, we're going to be looking at the sectors of production. We're going to look at the different sections in as far as the variable inputs are concerned, and we're going to be covering the content that we didn't manage to cover during our session in class. So this is the video that covers these aspects. So what we're going to cover in this section, we're going to look into these sections in your textbook. We're going to look at pages 46 to 49, 94. So they are quite essential. As you notice, the slideshow, we just use a lot of illustrations. There isn't little theory. So you're supposed to cover these sections in the textbook. Sections are from page 46 to 94. That will help you in understanding more this content. Then let's look at the concepts that we're going to cover during this class. We're going to look at the competitive input in markets. We're going to look at the supply curve of the variable input. We're also going to look at the demand for that variable input. Then we're going to look at the backbending supply of labor. We're going to look at fixed and semi-fixed inputs. Also, we're going to look at the imperfect input markets. We're also going to look at monopsony when it comes to labor. We're also going to look at the impact of a minimum wage on a monopsonist. We're also going to look at the bilateral monopoly position in a labor market. Also, we're going to look at natural resources as inputs. Also, we're going to cover what isoquants are, look at factor cost changes, look at the long run net return, then finally the elasticity of substitution. So that's the content that this video will seek to address. However, our starting point is to do with the determination of equilibrium for a variable input. So the equilibrium price is determined by that graph that you see there, where P is equals to 1. So you can see there's a normal demand supply curves. So where your normal demand and supply curves meet, that is the equilibrium price. So you can see there, your demand curve is downward sloping, indicating that of a variable input, which is an input of production, less is demanded at a higher price. So if the input is costing more, less of it to be demanded. Then if the input costs less, more of it to be demanded. So it becomes more or less like a normal downward sloping demand curve, the one that you experience even for a demand of a commodity. Then you have an upper sloping supply curve, which shows you that more of a variable input will be supplied if the price is high, and less of a variable input will be supplied if the price is less. So where your demand and supply curves intersect, you get your equilibrium, which is P1, the price, and it is shown there that your price is actually your marginal fixed cost. So when you talk about your MFSC, your MFC, we're talking about it representing a section of your fixed cost. So your price is more or less like your marginal fixed cost there. That's what your MFC is. We're talking about your margin, not marginal fixed cost, rather, your marginal factor cost. That is what your MFC is. So that is your MFC there. So it borrows from the terms that you normally know, that we would have covered in your first year when you talk about marginal cost. So this one is the marginal factor cost, as in this is the cost of your input. So it is determined by the forces of demand and supply in that section. Then let's talk about the equilibrium position of a firm for the variable input. So this is a very important graph, which shows us why a firm might produce even though it is experiencing economic losses. So we'll start by defining a few terms in this graph. So you do have your curves there, the MRP, which is the marginal revenue product. You also have your average revenue product, which is ARP. Then you have your net average revenue product, which is shown by ARP dash. So that one is not the one that we're going to look at. So let me give you a bit of background. A firm will maximize profits where your marginal factor cost is equal to your marginal revenue product. So this tells us that the firm will keep on employing the input until the identity of MRP is equals to MFC. MRP being the marginal revenue product and MFC being the marginal factor cost. So you remember from the information that you covered in first year that production occurs up until a point where your MR is equals to MC. That is how you maximize the revenue in a perfectly competitive market structure. So in this case, you don't have MR is equals to MC, but we do have the marginal revenue product and the MPC. So if there's an imbalance, let's say your MRP is greater than your marginal factor cost, the firm will employ more units until we gravitate to that equilibrium. If your MPC is greater than your MRP, the firm will employ less factors of production until we gravitate to that equilibrium. So there are a number of points to look at there. We're going to start when the price of the variable input is equals to PN1. So at PN1, what is important to notice there is that the company is employing NA units, and the equilibrium condition that we're talking about, MRP is because MFC is met because there's an intersection of your MFC1 line with your MRP line. So at this input level, what is important to note is the firm will generate economic profits. How? The economic profit is because the average revenue line lies above your MFC line. Another way to look at it would be to look at the total revenue generated by that firm. The total revenue generated by that firm in that case is your ARP, the line A, the ARP times NA. That is the revenue that is generated by NA units of the input, and this exceeds the cost of deploying those units, which is given by PN1 times NA plus fixed costs. So you can see there at point A, your ARP curve lies above the MFC, and I've just told you that the total revenue is the ARP times NA. So in that essence, it means the firm will be enjoying economic profits. So for any input price which is lower than PN2, the firm will recognize economic profits if it employs the variable input according to the equilibrium condition. MRP is equals to MFC. Then when we go to PN2, we see that there's an intersection there, intersection of the ARP and your MFC2. So at that particular point, the total revenue generated by the firm ARP times N is equal to the cost curve, which is PN2 times NB. So hence, at that point, the firm is making what you call normal profits. So normal profits is a point where a firm is neither making a profit nor a loss. So that is the price level at PN2. The firm is neither making a profit or a loss in that point. Then if you go on to PN3, at PN3, the firm is making now economic losses, right? Because the revenue, it is given by your ARP, your ARP times NC, while your costs are given by your your costs are given by PN3 times NC plus fixed costs. So you can see at that point, there are losses which are incurred. But it is not shut down level yet because the firm is still enjoying some coverage towards its fixed overheads. So it is covering part of its variable cost. It is covering its variable overheads, but a portion of its fixed costs. So as a result, that firm will continue producing at that point. Then at PN4, that is called the shutdown point. So this is where the firm is not even covering none of its fixed overheads. So at a price of PN4, this firm will consider shutting down because it is as good as not operating because they're not covering any of their fixed overheads. So that one is called, that curve represents the individual short-run demand curve of your variable input. That's what this diagram represents. The downward, the starting from the MRP, the curve represents the individual short-run demand curve. That is, if you look at short-run point up to the point where we're making economic profits, which is point A. So something worthy to note there. Then now, let's move on to the next point, which is when we look at that case study. So that case study, we want to look at the equilibrium condition in that case study. So we're given information about total output, which is 4, 10, 18, 28, 35, 39, 42. So we want to get an equilibrium point and we want to calculate what is the, in terms of production, what is the output level that leads us to equilibrium. So your equilibrium is when your MR is equals to MC. In this particular case, it will be MRP is equals to MFC. So your MFC is your marginal factor cost. And we are given in the information of the question that the cost of the variable input is 30 pounds. So your MFC is equals to 3 pounds. So we use the table to work out our total for our MRP. So we have this column of MO, which is 4, 6, 8, 10, 7, 4, and 3. So these are your marginal output. Then you have to multiply this by the price of the final product, which according to the information given in the question, it is 10 pounds a unit. So you get 4 times 10, which is 40, 6 times 6, which gets 60, 8 times 10, which you get 80, 100 times 10, which you get 100, 7 times 7, which is 7 times 10, which is 70, etc. So you will see that your marginal output, your MRP, reaches 30 at an output level of 7. So MRP equals to 30 at an output level of 7. That's why MRP, which is 3 times 10, 30. This is equal to MFC, indicated in the question that the variable input is 30. So since your MRP 30 is equals to your marginal factor cost of 30, the output level of 7 units is your equilibrium output. So the important point to note in there is that you have to work out your marginal output. After working out your marginal output, you multiply by the final price of the product. Then you look at that output level where your MRP is equals to MFC, and that is where the output is 7. So very important calculation there. Then now let's look at something interesting, which is the supply for labor. We introduced the backbending labor curve. So what is happening there with the situation where this is found in pages 53 to 54 of the textbook. So we have a situation where there is a worker. So that worker is earning 35 pounds per hour and they are working 18 hours. So if you take that 18 and multiply by 35, you get that the total cost, the total amount that they can probably make maximum is 630. This is shown by R1 in your graph. However, the person maximizes their utility with the money that their income is tangent to the indifference curve. So it is tangent at point A. So at that particular point at point A, as you can see there, the amount that is being earned by the person is 350. So from that situation, it shows us that they have 8 hours of leisure and they're making 350, 10 times 35, which gives us 350. So that is the 350 that they're currently making for working 10 hours. So another important things to note, I1 and I2 are in different curves for the individual contractor. Then you do have the income lines, which I've already mentioned there. So for analysis to get richer, we have to look at a point where there is a wage increase. In our initial case, where we started this analysis, our wages was 35 rand, 35 pounds per hour. Now let's assume, this is found on page 54 of your page, that the wage increases to 50 pounds per hour. So now the maximum amount that this guy can make, it is a 50 times 18, which is equivalent to 900. So this is shown by point R2 in your graph. That's the maximum amount that they're willing to make However, and also your income line shifts from ARA to ARA2. So the income line now shifts to ARA2. It was at ARA1, now it shifts to ARA2 because of this income shift. And now this contractor can move to a higher level of income, and they can now go to a higher indifference curve as a result. So eventually we do have a new equilibrium combination of your working hours and leisure time, and that is given by your new point, which is point B. So point B is the new combination of labor to working hours with the highest possible labor indifference curve is tangent to the new income line. So now let's analyze the movements. So you have a first movement from A to B. This is made up of two movements, A to C and C to B. So overall, the movement from A to B, this is known as the input price effect. So this input price effect consists of two movements. So the first movement is from A to C. This is known as the substitution effect. So we get this when leisure time is viewed to be more expensive and it is substituted for more working hours. So that movement from A to C on the original income line is where the guy is substituting more leisure for work, and leisure is becoming more expensive. Then we do have the second movement from C to B. This is known as the income effect. The income effect, we get it because now the person, because of the marginal tax rates, they argue that they can generate the same amount of income. Remember before they were generating the 350 by working 10 hours. So now they argue that they can generate the same income by working less hours. So 350 divided by 50, it is 7. So now they argue that they can rather work 7 hours instead of 10 to make more money, and thus leisure is more preferable to working hours. So that movement from C to B is illustrating what we call the income effect, where people now realize that they can make the same amount of money as they were working before. So now they decide to work less hours because of tax rates, high marginal tax rates. They decide to work less hours to make the same amount of money as they were working before. So this introduces a nice phenomenon, which we call the big pending supply of labor. So initially, if you increase your work rate, people are willing to work more hours up until they reach point A. So at point A, that is the point where we saw in our initial diagram where the person decides to work less hours to make the same money as they were. So people, the supply curve of labor is backward bending because people are willing to increase their working hours for wage levels higher than PN1 until they get to a point A. At point A, they are now more interested in leisure, even if you increase your pay, the price of the labor, people will work less hours, which shows us why that curve is big bending to show us that even at high levels of income, people will still stick to that wage rate and they'll substitute it for more leisure hours. So this explains the big bending curve of labor. Then we have this diagram, which is talking about your fixed inputs. So this diagram shows us in the short run that your input price is in the short run. If for a fixed input, it is entirely determined by the demand of that input. If there's an increase in the demand of that input, this most likely will result in the increase in the price of that input. So in that situation, you can see we are talking about a fixed supply curve in the short run. So the determining factor there would be increase in demand. Increase in demand, which shifts your prices from D1 to D2, that shifts your price from P1 to P2. Then now let's look at the caps of monopsonist. Now we're looking at labor supply. So a monopsonist, let me first of all define what a monopsonist is. So we have a situation there when we're talking about a monopsonist. So a monopsonist is a condition where there's only one single buyer for the import. In this case, we're talking about a labor market where there's only one employer for a certain skill in the labor market. So a monopsony can occur for a variety of reasons. In some cases, a particular type of import is much more productive than its usage. So that you have your monopsony diagram there. So we have our illustration there that you can see, P18. So we are talking about a monopsonistic situation in the labor market. So we have the marginal revenue curve, MRP curve, which stands for the demand for your labor curve. Then we do have the supply of labor curve, which is illustrated by SL. Then also have the marginal spending, MSL, which represents the change in input spending when an additional unit of labor is employed. So let's look at a few analyses there. If the marginal revenue product is greater than the marginal spending of labor, MRPL greater than the MSCL, then it means the employer will employ an additional worker because it pays more to employ the worker as it is more productive than what it costs us. If the marginal revenue product, however, is less than the marginal spending, the employer will not employ the additional worker. So the optimal units that the employer is willing to employ will be at a point where MRP is equals to MSL. So where your MSL intersects your MRP, that is where the employer will employ the workers. So you can see there the number of employees is NM and the wage rate is WM. So it is WM, not a higher wage rate. The answer is simply that NM units of labor are prepared to work at a wage rate of WM. So that is your NM there, your NM, which is the number of workers employed, and your WM. So in this situation, in a perfectly competitive market, we can also extend this analysis to talk about a perfectly competitive market where we look at the equilibrium under that case. So in a case where you have a perfectly competitive market, NPC, number of workers are going to be employed, and that wage rate is going to be WPC. And for the perfectly competitive market, we will look at where the supply curve is intersecting your MRPL. So you can see the impact of that is in that particular case, in a perfectly competitive market, more workers are employed, which is shown by the difference between NM and MPC, and also their wage rate is higher compared by the difference between WM and WPC. So PC being the perfectly competitive market compared to the monopsonistic market that we have there. Then we move a step further. We go to imposition of a minimum wage. So in the case of an imposition of a minimum wage, you can see the minimum wage is shown there. So the impact of the imposition of the minimum wage, it is studied in the diagram that you see in that particular section there, which is B14. So again, you have your marginal spending curve, which is now the horizontal from O to N1. This simply means that the wage is fixed for any unemployment level in the region of 0 to N1. The equilibrium level of employment given the minimum wage, it will occur where your marginal revenue product is equal to the marginal wage. So your marginal product is equal to your minimum wage. So both employment levels, you can see, the employment level increases compared to the monopsonistic market, NM to NM minimum, that's the number of workers employed. And also the wage rate increases from WM to W minimum when you compare the monopsonistic to the union minimum wage. However, it is important to note that employment will not increase if the minimum wage is greater than W star. There is a W star on top there. So the minimum wage will not increase employment if it is greater than W star. The effect will be to reduce employment. So very important analysis showing us that if you implement a minimum wage, compared to the monopsonist situation that we saw earlier. Imposition of a minimum wage can increase the wage rate as well as increase the number that are employed. That is the analysis they issue to extend the minimum wage in the figure that is shown there, figure B14. Then there is another situation, which is a case of bilateral position in the labor market. So this bilateral monopoly situation is a scenario where both the buyers and the sellers of inputs have control over the setting of the price level. So the figure that is shown there, it is your B15. That's the figure where we get this analysis from, your B15. So the position of the monopsonist remains unchanged. The monopsonist will demand NM units of labor at a wage rate of WM. So this is where MRP is equal to MSL. The labor union is a monopoly over the supply of the labor. The most optimal position for the labor union is such that the marginal cost per additional unit of labor supplied is equal to the marginal revenue per additional unit of labor supplied. So the optimal units of labor supplied in this case by the union will be NLU at a wage rate of WLU. So keep in mind that the wage demanded by the labor union is derived by the MRP curve of the employer. So there is a curve there, the MRP curve of the employer. It can be clear from this analysis that the wage offered by the employer, monopsonist, differs from the wage demanded by the union. Collective bargaining will eventually determine the wage rate and employment levels at the end of the day. So if the union is a stronger party in the bargaining process, the final wage rate will be closer to WLU and the number of people employed will be closer to NLU, respectively. If, however, the monopsonist is the stronger party in the bargaining process, the wage rate will be closer to WM and the number of people employed will be closer to NM. So very interesting analysis theory. We have a union and a monopsonist. It shows us which party has the stronger bargaining point. If it's the union, the wage rate tends to be closer to WLU and the number employed to be closer to NLU. While if it's the monopsonist, the wage rate to be closer to WM and the numbers employed to be closer to NM. A very, very interesting observation there. All right, let's go on to the next section where we want to look at your natural resources as inputs in your production process. So this diagram is showing us a situation where we have a plantation and we decide then we want to utilize extra units in our plantation. So the situation that is described there, it is a hypothetical plantation where we are growing our timber for a given period of time. When it reaches maturity, then logging can occur. So obviously there are initial costs that we have to bear in mind, like establishing the plantation, maintenance cost of the plantation, working cost. Those must be taken into account when we do this analysis. So we need to look at that. So in economic theory, we have to look at the real average cost per tonnage of logs. The wood decreases, productivity is increasing. So in this case, greater tonnage of logs is only possible over a certain period of time. So we have a diagram there. For smaller tonnage of logs, the real average cost per tonnage will be greater. The question to be answered is, at what point will the real average cost hardly of a ton of logs be equal to or less than the benchmark? So we look at the analysis now on the graph that you see, graph A and graph B. So graph A represents the real tonnage growth curve. So you can see over time the growth rate curve increases and it eventually reaches a maximum growth rate reaches a maximum growth rate, matures after a period of Tmax. After Tmax, would have reached our maximum growth rate. The potential real tonnage of logs decreases because of natural factors, because we would have surpassed the optimum point. Then the analysis extends to figure B. to where we have our benchmark real average cost per tonnage of logs. So if the benchmark real average cost per tonnage of logs, if that is equal to the real average cost at the maximum growth rate, it'll be beneficial to start logging a period of Tmax. Let me repeat that one more time. The benchmark is the benchmark real average cost rate per ton. If that is equal to the real average cost, the maximum growth rate will be beneficial to start logging a Tmax. So the benchmark would be what we pay. Think of it as the rate that we pay in the market if we were to source to buy our material. Then we have the real average cost, which is the cost in our plantation. So just to take that one more time, if the benchmark is equal to the real average cost at the maximum growth rate, it will be benefit for us to start logging at Tmax, as you can see there, the graph at the bottom. But there's a question of this will be at point B. So the alternative question will be, why not at point A much earlier? So there is a point A where your benchmark is equal to your real average cost of tonnage. The simple reason is that the real tonnage is much greater at point B than at point A. So which is why we stick to point A, because you can see at point A there, yeah, that is where your benchmark real cost per tonnage can be equal to your real average cost, which is point A at point B. So if the benchmark real average cost per ton is lower than the real average cost at the maximum growth rate, the firm will only start logging at period T benchmark. The real average cost of logs is lower at point C compared to point B, possibly as a result of lower maintenance cost of the plantation. And as well, the real average cost per ton is low at point C compared to point B because with lower maintenance costs after the plantation has reached maturity. The firm will source logs externally up to a point where T benchmark. Then after T benchmark, it will start logging its own plantation. So it's a nice illustration showing us where we can source our resources, our logs outside, and when we start making them. So to summarize, the firm will source its logs externally up until a point where we get to T benchmark. That is where it will start logging from its own plantation. So there's another similar case study where we look at uses of electricity. So this is the next slide where we look at conversion from electricity to your solar. So we can see in that illustration that we are looking at your exhaustible resource to a renewable resource. The exhaustible resource is electricity, obviously. And then we have a renewable resource, which is solar technology. So as long as the real average cost of the exhaustible resource, which is electricity, if it's less than the real average cost of renewable resource, which is solar, the firm will continue using electricity. The firm will only convert to the alternative renewable resource when the real average cost per unit, which is the initial cost plus maintenance cost, is less than the real average cost of the exhaustible resource. So looking at our diagram, before the time period T, the real unit cost of electricity is less than the real unit cost of solar. So the firm will only convert to solar after the period of time T. So the conversion to solar can only occur at T, provided we have the necessary technology which lowers your solar energy cost to the lower graph, which is adjusted unit cost of solar energy. So that T star, we can make the switch if we have the requisite technology to lower our unit cost when harnessing solar energy. But in a normal case, the switch point will be at point T, where we switch from electricity to solar, because beyond point T, utilizing solar is actually cheaper than your electricity. If we have the technology beyond T star, it will be useful to use your solar shown by the adjusted unit cost compared to the electricity, which is a bit expensive. So this graph is a very important graph. So that graph is a very important graph, which shows us when we can switch to alternative resources of energy. So this is found between page 60 to 61 of your textbook. Then let's go on to ISOQuant. So we have a graph there. So we have your ISOQuants that are shown there. So we are looking at different combinations of your capital and labor. So your vertical axis is your capital, then your horizontal axis is your labor. So there we have a locus of points from A, B, C, D that shows us different uses of capital and labor, but that gives us the same output. So we term that an isoquant. So in isoquant, it is a two-dimensional representation of technology, given it's a two-dimensional representation of the technology, defined set of production, given a specified quantity combination of capital and labor, and a unique level of output. So points A, B, C, D is an isoquant. They are all same output level. However, we're using a different mix of your labor and capital. T1 being the most T1 being the most capital intensive because we're utilizing a lot of capital there, and T2 being the most labor intensive because you're utilizing a lot of labor there. And we have different combinations of capital and labor in between, all of which are giving us the same output level. That's the important thing to note. So isoquant Q1, it illustrates 5 technologically defined processes of Q1 units that goodies can be produced. So there's combination A, it is the most capital intensive, like the one that I've said above. Then as well, you have your point F, which is your most labor intensive. Then the other points are different combinations of your capital and labor. Then we have this identity. So this identity seeks to show us that what we call the marginal rate of technical substitution, MRTS. So your MRTS is your slope of an isoquant because it shows us how we are able to substitute your capital and labor units, how you can easily substitute one for another. So the slope of that isoquant is the MRTS that you see there, and that slope, it is defined by the equation that you see there, where you have your MRTS, which is change in capital over change in labor. And we have your marginal productivity of capital, which is change in the quantity of capital, divided, change in the quantity divided by the change in capital. That's your marginal productivity of capital. Then you have your marginal productivity of labor, which is change in total output divided by the change in labor. So if you solve that one, you discover that your MRTS at the end of the day, it is the marginal productivity of labor divided by the marginal productivity of capital, and it is negative in sense because it's a line with a negative slope. So it tells us that the more labor is employed under a small MRTS, and the more capital will be employed under a great MRTS. It becomes a useful standard rule to be applied later. So what is important there, it is to notice that your MRTS, it is a negative slope and it is smaller when we're using more labor, then it becomes greater when we use more capital. Then moving on that analysis, we have it takes us to a point where we have our isoforce curve. So this is found on page 69 of your textbook. So we have a budget element there. So we have a budget element there. Then we have the price of capital. Then we have budget Then you have a price of labor. So this is the price, this is the budget constraint, which limits the number or the factors of capital that we can employ for both your labor and capital. So those factors are restricted by the budget constraint there. So the slope of your budget line is given by the price of labor over the price of capital. Your intersection in the capital axis, you take your budget line, divide by the price of capital. Then your intersection as well in the labor axis, you take your budget, you divide by the price of labor. So the slope overall then becomes the price of labor divided by the price of capital. You will see it becomes important when we want to determine later on the number of labor and capital which we'll employ in our production process. So this takes us to, the preceding analysis was in page, 71, where we look at the production budget constraint. So from there on, we move on to another page in the textbook, which is page 74, when we try to look at the equilibrium point, right? So this analysis is the analysis at your long run factor mix cost. So the circumstance is illustrated by your figure B21 there. So we have a point of tangency of your isoquant Q1 with the lowest attainable iso cost. So the iso cost is that straight line that we saw in the previous slide that cuts your capital axis and labor axis. That is called your iso cost line. So the point of tangency of Q1 with the lowest attainable iso cost line, this is a point E. So at this point, the entrepreneur achieves the minimum operating revenue. They are also achieving maximum efficiency in the import. So the tangency between the iso cost and the iso quant represents an equimarginal condition of allocative efficiency that we need to know. So the slopes of the iso cost curve and the iso quant, they are equal. The iso cost being straight line and the iso quant being the curve there. So we have an equimargin condition, which is the price of labor divided by the price of capital. This is equal to the marginal productivity of labor divided by the marginal productivity of capital. So this is an equation in the page 73 of your textbook that you need to study. So it shows us that the slope of the iso cost line, which is PL over PQ, this is equal to the iso quant slope, which is M marginal productivity of labor over marginal productivity of capital. So we are going to use that relationship in the preceding activity, which requires us to solve a few items. So we have the cost ratio of the two factors, as we have already highlighted there. So we have MPK, marginal productivity of capital, divided by the price of capital. This is equal to the marginal productivity of labor, divided by the price of labor. So this leads us to this case study that we're going to study, that is found in your images confirm. This case study, which case study is this one? So this case study was found in your page 72. I think this one is found in page 72 of your book. So with this case study, we're given the following information. Assume the following information. Capital is denoted in the vertical axis. So the question is guiding you to tell that your capital is in the vertical axis and labor on the horizontal axis, and you have a budget of 200. So 2,000 pounds rather. So you would need to calculate the maximum affordable units of capital. The maximum units affordable of capital rather are 20, and the MRTS is given by 4. So from this information, we're going to determine the prices of the two inputs and the maximum affordable units for labor. So from the information given to us, you can see that we're given a budget of 2,000, and we are told that the maximum affordable units are for capital at 20. So you can use that identity of maximum units affordable for capital, and you're told that the MRTS is equal to 4. right? So we're going to use that MRTS to calculate something very important there for your labor. So remember from the previous analysis that we have done, the MRTS is the slope of your isoquant, right? So it is slope of your isoquant. So we know that the slope of our isoquant, it is 4. So given the information that we have, we know that we have a production budget of 2,000. What you can do to utilize that is also you're told that the maximum affordable units of capital is 20. So if your maximum affordable units for capital is 20, if you take your 20,000, you divide by 20, you get that the price of your capital is 100. So for starters, you know that the price of, if you solve that equation, you discover that if your price of your price of capital is 100, right? That's your price of capital. And we know as well that your MRTS is 4, right? So if the MRTS is 4, if your price of capital is 100, this means that your price for labor is 400 based on the MRTS, because we're told that the MRTS is equals to 4. So it means your price for labor becomes 400. Then you can use the price of labor to find the maximum affordable units of labor, which is 5. So I guess the most important thing to note there is your MRTS. And remember what we said about your MRTS. We see this is the slope of your isoquant. And how do you get your MRTS? We see the MRTS, it is the marginal productivity of labor over the marginal productivity of capital. And we had said at equilibrium, another important thing to note, which was important, we said in the preceding slide, at your equilibrium, MRTS, which is MPL over MPQ, is equal to the price of labor over the price of capital. So we use the budget constraint to establish that the price of capital was 100. We got that by taking 2,000 divided by maximum affordable units of capital of 20. We got that the price of capital was what? Was 100. Therefore, PL, which we're looking for, divided by the price of capital, which is 100. This is equal to MRTS, which is equal to 4. So which cross multiply there, because that the price of labor was 400. Then if the price of labor is 400, it means the maximum affordable units was 5 for labor. So nice equations to note that become handy. You need to know those equations of price of labor over price of capital is release your MPF over MPK, marginal productivity of labor over marginal productivity of K. So that equation 20 becomes useful in this case study. So something that you ought to know there. Then we have another case study here. We have a case study where we have your units of labor, units of capital. You are given that the maximum affordable units of capital is 200. Then the price of labor is 10. And you're given that the MRTS is -2. So we know from the preceding section that the MRT is -2 because it is a negative slope. So we want to, first of all, to work out, we want to calculate our price of capital from the production budget. We're given that the maximum affordable units of capital is 200, and we're given that the price of labor is 20, is 10. So using our equation of price of labor over price of capital, which is equal to MRTS. So we take 10, which is the price of labor. We divide by the price of capital, which we're looking for. This is equals to 2. If you solve that equation, you get that your price of capital is 5. That is your step 1. So you have established your price of capital. Then from then on, you want to see what is our budget. We want to use the price of capital to compute our budget because we are told the maximum units of capital are 200. and we just calculated that the price of capital is £5 per unit based on the MRTS. When we said turnover price of capital is equals to 2, we solved that and we found that the price of capital is 5. So 5 times 200, which gives us a budget of 1,000. So we know that we have 1,000. That is our budget, £1,000. So this will come in handy when we want to test our combinations, which ones are working. So if we want to look for the proper inputs of capital and labor, we have to compute another column. So that column would be your marginal productivity of your capital divided by the price of capital. Also, you have another column of marginal productivity of labor divided by the price of labor. So we have those units of capital and we have those units of labor in that particular case. So we can compute our marginal output. We can start by computing our marginal outputs from the information that we've been given there. So we have our units 70, 60, 50, 40 for labor. Then we have our units for capital as well. So we want to look at the marginal productivity. So the marginal productivity of your capital, we would take the marginal output that we're given, which is 80, we divide by the price of capital, which is 5, which gives us 16. We do the same for 70. We take 70 divided by 5, we get 14, which is shown in the, let me see if I can go there. Yes, which is shown in this section now. So we have your MPC of a P column, where you're taking your marginal output and you are dividing it by the price. We see it 80 divided by 5 for 60 units of capital. Your marginal productivity will be 16. So that is your marginal output divided by the price of capital. Then for 80 units, it will be 70 divided by 5, which gives us 14. Then for 100 units, it will be 60 divided by 5, which is 12. Then for 120, it will be 50 divided by 5, which is 10. For 40 units, which is really, for 140 units, it will be 40 divided by 5, which gives us 8, etc. If you do the same for your labor, for 70 units of labor, it will be 40 divided by the cost of labor, 4, 10, which gives us 4. Then 50 for 60 units of labor divided by 10, which gives us 5. Then for 50 units of labor, it is 60 divided by 10, which gives us 6. So there are 3 possibilities here. We have to look at where your marginal productivity of capital divided by the price of capital, where it is equivalent to the marginal productivity of labor divided by labor. So we have a situation where we have both 10 in the marginal productivity of capital divided by the price of capital. So this 10 corresponds to 120 units of capital. And when you go to your labor, this 10 corresponds to 10 units of labor, which is why we have 120C is equals to 10L there. Then we also have 8, where you have 8, where your marginal productivity of capital divided by the price of capital. And also you have your 8, where your marginal productivity of labor is divided by the price of labor. So the 8 in the capital corresponds to 140C, while the 8 in the labor corresponds to 30 units of labor. Then finally, we have a point where all of them are equals to the last coordinates of the points will be all of them are equal to 6. So for your capital, this will corresponds to 160, and for your labor, this corresponds to 50. So you test your both of these in the budget line, because we know that our constraint is a budget of 1,000. So if you substitute 120 times the price of capital plus 10 times 10, this is not equal to 1,000, because that will be equal to 600 plus 700. So our capital is not exhausted when we use 120 units of capital and 10 units of labor. If you go to 88, that is equals to 1,000. If we go to 160.50, our budget line is exhausted. So the least cost combination there, it is the 140 units of capital, and 30 units of labor. So that will be our solution in that particular case. So a nice calculation that you guys need to know, which is important. Then as well, we have another case study there. We are looking at, here we're looking at a manufacturer of home appliances. So they have that production function there, where you have your 40L minus L squared plus 5C minus 1.5C. Then you have the input cost, where your price of labor is $10 and your price of capital is 15. So that's the information that you have there. So in that particular case, the first step will be to derive the partial derivatives that we used in the previous section. They become handy there. So you get your marginal productivity of your labor. So you differentiate with respect to labor. So you get 40 minus 2L. Then you also differentiate with respect to your capital. So if you differentiate with respect to your capital, there's 54 minus 3Q. Then you divide each equation, the MPL, you divide by the price of labor. Then you divide the MP, the prime marginal productivity of capital, by the price of capital, which is 15. You end up having an equation of which simplifies this to L is equals to C plus 2. Then this becomes equation 1. Then you also have your budget constraint, because we are given that the production budget should not exceed 220. So 10, which is the cost of labor, multiplied by L plus 15 multiplied by the price of capital. This is equals to 220. So that is your constraint. So you solve those two simultaneous equations like you have been solving them throughout. So when you solve this simultaneous equation, it gives you a value of labor of 10 and the value of capital of 8. So we have this input mix of capital units of 8, labor units of 10, which satisfies the relationship. And if you substitute this, you discover that your quantity is 636 units. So the firm's total cost as well, if you substitute this, if you substitute the input prices there, you discover that the total cost, it is indeed 220. A nice analysis there. We use partial derivatives and use the budget constraint to find the relationship, the number of units of capital and labor of where we need to produce. So a nice concept which borrows from the concepts that we've done earlier in our section. Then we have another section, which is page 76 in the textbook. Here we are talking about changes in your cost of labor. So initially, in your diagram A, labor becomes less expensive. That's why we are utilizing more units. That's why I'm moving from 1 to 2. So in figure A there, we discover that there's a cost in change and the labor cost is changed and we become more intensive. However, in B, the labor cost increases, we become less labor intensive. So that's why the line is moving inwards, showing us that labor is becoming more expensive. Then the same analysis applies to capital. The first one, C, is where capital becomes cheaper, as shown by the movement from that capital B over PK1 to B over PK2, which is your C diagram. So becoming more capital intensive. Then in D, we're becoming less capital intensive, maybe because capital is becoming more expensive. Then we have your final one, which is E, where labor becomes expensive, maybe because of union negotiation. And simultaneously, we have an increase in the cost of capital, maybe because we have technologies that has made the cost of production quite cheaper. So you have that simultaneous change there. So these are nice analyses. You do them when you're analyzing your graphs. Then we have your long run returns. So this is figure B23. This should be figure B23. Let me look at that. Yes, it's figure B23, which is found on page 79. So here we're looking at how you would look at your constant returns to scale. So with your constant returns to scale, if you stipulate that if you increase both your outputs by the same constant, this will result in your output also increasing by the same constant. So these are constant returns to scale. So if you increase your inputs, which is both your labor and capital, by M, this will result in the precise increase in your output. So if you're using a technological, if you're using a technology, the expansion in output is similar to the changes in proportion of your labor and capital that you're using. So that's constant returns to scale, which is slightly different. Also, if we were to plot it on a returns to scale, it becomes an upward sloping line, showing us uniform changes in your labor and capital yield to changes. You have different equilibrium there, illustrated by figures. So what you have there is you have your ISO costs, which is what we looked at before, which is B1, B2, B3, B4. And they are isoquants that are labeled as L1, L2, L3, L4. The significance of that is when output is doubled, also operating revenue is doubled. So these are constant returns to scale, showing us that whatever is happening on your input side, it translates to your revenue. So we have a relationship where those are what you call your constant returns to scale. So if you double your inputs, it also doubles your output. So the rest of the remaining slides, I think you can go over this just to get your own, this remaining part you can self-study. So it is important to notice that in this video, the important elements that we have covered, we covered very important elements ranging from your returns to scale, the last part of which you're going to self-study. We looked at isoquants, we looked at isocost curve, we looked at our equilibrium when we are solving. We were looking at the quantities for labor and capital, which was important. We also looked at your, as well, we looked at the start, we looked at your production, switching between production from one source of power to another. We looked as well at your labor market, the monopsonist as well. Very important things there. The diagrams. We also looked at the backward supply of labor. We looked at the income changes here in the supply for labor, as well as we looked at the short-run demand curve of a variable input. So all these are very critical. Go through them. Even the section from the slides 26, which are self-study, go through it, make sure you understand it, because all this content is going to be tested in your assessment one. Your assessment one comprises of the stuff that we covered together in class, which was section A, along with the content that's been addressed in this video. So make sure you cover all this so that you are ready for your assessment. All the best. Study this video, make sure you understand the concept, and most importantly, refer to your textbook. As you can see that here, it is basically diagrams and there's very little theory that is there. So refer to your textbook so that you can get more understanding of these various concepts. Have a lovely day. See you next time when you have a face-to-face session. Make sure you study hard for your assessment one.